So all three of these shapes have the parallelogram properties. Okay, so all three of these are types of parallelograms. So what were the parallelogram properties from yesterday? Can anyone tell me one? Just one. The diagonals bisect each other. Opposite sides are congruent. Opposite angles are congruent. That's one of the ways we prove them, but its consecutive angles are supplementary. Okay, so those four properties will also apply in all three shapes. I'm not going to rewrite all four. Just make sure you remember that all three of these will have those same four properties. All right, so shape number one. Let's talk about a rectangle. So what is special about a rectangle? So it is a parallelogram. But it has something special about it. It's a parallelogram with four right angles. So all four of these, whenever you have four right angles, you have a rectangle. Now, because it's a parallelogram, it has those four properties, but because it's a rectangle, there's one more that can get added to the list. But this one only applies to a rectangle. And it has to do with the diagonals. The diagonals bisect. Nope, not bisect. That's part of the wrong one. The diagonals are congruent. So if you were to connect the opposite corners, those segments would be the same length. Now, because it's a parallelogram, we also know that the diagonals bisect each other. So if we have two equal segments, and we know that they're cut in half, what do we know about all four halves? They're all the same, or they're all congruent. So what does that make on the inside of our rectangle? So if you were to cover these up, what kind of triangle is that? Isosceles. What kind of triangle is that one? And what about that one? And what about that one? So in a rectangle, when you draw the diagonals, you get four isosceles triangles. That's something that can help us when it comes to finding angles. Because of the fact that these are all isosceles, I can use base angles congruent to help us find out more information. So that's something that's special with the diagonals in a rectangle, is that it can create isosceles triangles on the inside. Okay, so let's do an example like what you have in your assignment. You have rectangle MNPL. And I'm going to tell you that LN is equal to 5x minus 8, and MP is equal to 2x plus 1. Solve for x. So how might we solve for x? William, what do you think?
You just make them equal 5x minus 8.
All right, so LN is the diagonal over here, and MP is the diagonal over here. Using our new property, we know that LN has to equal MP. So if we set 5x minus 8 equal to 2x plus 1 and solve, so subtract 2x, add 8, we get 3x equals 9, so x would equal 3. That's pretty much what the problems on your assignment are going to look like, where you use your new property to help you set up an equation and solve. Okay. Any questions about rectangles at this point? Okay, on to the next shape. Our next shape is a rhombus. So when I'd asked you earlier which of what you knew about these, no one really mentioned much about a rhombus. Has anyone seen a rhombus before? Okay, a rhombus similar to a rectangle, it is a parallelogram with, now William, you had your hand up. What were you going to say?
I was gonna say, rhombus has all four sides equal, but then the angles are 90 degrees.
Okay, we don't need that second part. Just as long as all four sides are congruent, we have a rhombus. And I'll tell you why I'm not going to say that first part, and because we'll talk about that after this. Okay. So a parallelogram with 4 congruent sides. Okay, so this one, the angles don't necessarily have to be 90. Doesn't mean they can't be, but it just means they don't have to be. So because we have a parallelogram, we have the 4 properties from yesterday plus 2 more. Okay, rhombuses have 2 additional properties on top of the 4 that go with a parallelogram. The first one, actually they both have to do with the diagonals. The first one says that the diagonals are perpendicular to each other. So what does perpendicular mean? Makes a 90-degree angle. So that means all 4 of those angles where the diagonals meet are all going to be 90. The second property that goes with a rhombus says the diagonals bisect the angles. So that means each of these angles is cut in half by its diagonal. So we'll still have the 4 properties from earlier or from yesterday, plus the additional 2 listed here whenever we're talking about a rhombus. We're going to do 2 examples here, and both of these we're going to be finding the missing angle. So here's our first rhombus that we're going to find the missing angle for, or angles I should say. We have angle 1, 2, 3, and 4. Right there. And then this is our second one, where we're going to find angles 1, 2, and 3. So once you're done drawing, start thinking about what the properties we just went over are and how can they help us find angles 1, 2, 3, and 4. Now when everyone's done drawing, then we'll start to go over them. But if you finish drawing, start thinking, what can we possibly use to help us find angles 1, 2, 3, and 4? Okay, so does anyone think they might know how to find one angle? Adam?
Since that time the triangles are isosceles, the bigger ones, and 4 has to be 48.
Okay, so Adam was looking at this bigger triangle right here. So if you look at this bigger triangle, you have an isosceles triangle, which would make 4 have to be 58. Okay? Anyone else? Katie?
Angle 3 is 90 degrees because the diagonals are perpendicular.
Okay, so because our diagonals of a rhombus are perpendicular, we know that angle 3 has to be 90 degrees. Okay, so what about angles 1 and 2? Anyone have a thought maybe as to how we could do that? William?
Okay, so 58, the vertical angle, if you go to the other bigger triangle, you'll find that that one is like 58. So you 180 minus 58 minus 90, and you'll get angle 2 and 1.
Okay, so what William was saying is we know that all of these angles in here are 90. And so 58, we can also use the fact that the diagonals bisect the angles to know that this is also 58. So if we do 180 minus 90 minus 58, we can get angle 2. And because this is a diagonal, we know that 1 and 2 are the same because that diagonal cut that angle in half. So both halves have to be the same. So if we do 180 minus 90 minus 58, we get 32. So angle 2 is 32, and then angle 1 would also have to be 32 because the diagonals bisect the angles. Okay, looking at number 2. What do we know about number 2? Is there anyone that we know right away? Reagan?
Number 2 is 90 degrees.
Okay, so diagonals are perpendicular, so we know angle 2 has to be 90. William?
Angle 1 is 60.
Angle 1 is 60 because we know the diagonals bisect the angles, so this would also have to be 60. So what about angle 3?
30.
How'd you get 30?
180 minus 90 minus 60.
Okay, so if we use the fact that all of these angles in the middle are 90, 180 minus 90 minus 60, we get 30. And we know that this angle here and angle 3 are the same, so angle 3 would also have to be 30. This is what you're going to be doing with the rhombus problems. You're going to be finding angles and missing angles utilizing these two properties along with the 4 that we did yesterday with parallelograms. Okay, any questions so far on rectangles or rhombuses? We only got one shape left. Okay then. So our last shape today is a square. So when we were going over, and I was before notes, and I asked you what did you know, Adam gave us a really good definition of a square. Adam, do you mind repeating that?
There's 4 right angles and 4 congruent sides.
So it's a parallelogram with 4 right angles and 4 congruent sides. Another way to think of a square. What else has 4 right angles? A rectangle. So a square is a parallelogram. It's a rectangle. And what else has 4 congruent sides? A rhombus. So a square is all 3 of these shapes combined. So if you put all 3 shapes, a parallelogram, a rectangle, and a rhombus together, you get a square. That means that a square will have the 4 properties from a parallelogram, the 1 property from a rectangle, plus the 2 properties from a rhombus. So squares have 7 properties that apply to it. A rhombus has 6. Yeah, 6. The rectangle has 5, and the parallelogram has 4. So each of these has a set of properties, 4 that are the same, and then depending on the shape, they may have some added or not. So what you guys are going to be doing on your homework for the most part, if you look at numbers 1 through 4, you're going to be just identifying what shape do you see there. So you're looking to see, do you have a rectangle, a square, a rhombus, or just a parallelogram? Then you're going to have your rhombus questions, like the ones we did in class, followed by your rectangle questions, like the ones we did in class. Then if you flip to the back, you're going to start getting them kind of all mixed together. So if you look at 17 to 24 on the back, look at number 17. So it tells you that this shape is a rhombus. And it gives you these 2 pieces of information, and you have to figure out what is x. So what can we do to maybe find x? Thinking of our properties that apply to a rhombus. Anyone think they have an idea as to how we might solve for x knowing we have a rhombus?
Could you go 2 times 2x minus 1 plus 4x plus 28 is equal to 180?
Yep. Okay, so what Kendrick was saying is he was saying to double 2x minus 1. Okay, by doubling 2x minus 1, you're using the idea that, or the property that the diagonal bisects the angle. So this entire angle is going to equal 4x minus 2. And then using the parallelogram, we know that consecutive angles are supplementary. So 4x minus 2 plus 4x plus 28 will equal 180, and you can solve for x. This is the idea that the type of thing you're going to be doing on 17 through 24. You're going to be looking for what's given in the problem and what properties can you use to help you set up an equation to solve for x. Yeah.
Can I get that to go to
Okay, so the one thing on number 20, there's a typo. So can you look at number 20 real quick? Number 20 should say rhombus, not rectangle. Because if there's no way to make it a rectangle, but you can make it a rhombus. So on number 20, change that to rhombus, otherwise you'll be stuck.